Okay, welcome back to the Knologist. I'm going to be doing another question, and it's going to be remove duplicates from a sorted array. Okay, so why do I keep opening? This is like a habit of mine. I keep opening VS Code, and it just does what it does. You know what I'm saying? Okay, so I'm going to click that. Remove duplicates from sorted array. Okay. So this is supposed to be an easy problem. So given an array of nums in a non-decreasing order, remove the duplicates in place such that each unique element only appears once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. And then consider the number of unique elements to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not as important. Okay. As well as the size of nums. So return k. The judge will test your solution with the following code: int nums, expected nums. Okay, so this is the original array, the expected array at the end with the correct length. Remove duplicates, k, remove duplicates. Calls your implementation. If all assertions pass, then your solution will be accepted. Assert k, nums expected length. Okay, so it's going to look for the length. It's going to look for the numbers. And look at my traps. I'm about to go to the gym soon, so let's consume protein. I do have a meal prep that I take, so I had 2 servings of that, and then when I come back, I'm gonna have my protein shake, which is 40 grams of protein to 54 grams of protein. So I get around 120 grams per day by doing that, because I also had a sandwich in the morning. Side note, so it's not all about code sometimes. Sometimes you gotta prioritize dieting, health, fitness, wellness, sleep, right? Although I'm not one to talk about sleep because I don't get much. But I digress. All right, let's go on. So I'm not even going to try and do this the efficient way. Since it's an easy problem, all I give a shit about right now is just getting from A to B. It's not solved. There's a question, there's a problem, and I just want to get this solved. Right? Once I get to a point where I could just solve it, then like in another video or something, we could do optimizing. First, you want to know if your assertion or your logic and your way of thinking is the correct way of thinking. So solve it any way you can, the easiest way you can. And that way you kind of like mentally already prepare yourself for like, okay, I can at least come to a solution when worst comes to worst. Don't always think about optimizing. Optimizing is once you have something working. Like if I have a car, right? Is there any point in optimizing from 100 to 200 kilometers if the car doesn't even move? No. The first objective is make the car move. Then let's worry about how fast we can make it go, right? So like right now, my approach is just brute force it. So what I'm going to do is 2 loops. It looks like the simplest way to solve it is just 2 loops. So I want to go for I in range 0, 2, nums. I in range 0 to nums. I just want to see examples of the code. So 1, 1, 1, 2, 2, 2, 3, 3, 3. Remove duplicates. Non-decreasing. Non-decreasing. Non-decreasing means why don't they just say increasing? Because it's like over here. Where's the example? 1, 2. Oh, okay. So it's saying they want to add these little slots as the output to maintain the original length. So what I could do, the easiest way I could think of it, I don't even have to do a double for loop. I could just do a set. I could just create a set. So the good thing about a set is it only accepts one of each type of number. So I could just do a pass through the array, and whatever makes it to the set makes it to the set in that order. And then I can just add on whatever the length is of the remainder. So if I want to maintain this length, say it's a length of 7, and it goes up to 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. Right? So that 5, 6, 7, I can just add as blanks if there's duplicates in there. So first I'm going to do a pass of this array. And then let's see how to create a set. How to create a set in Python. Okay, let me do this. Create an empty set in Python. Boom. Create an empty set. X equals set. Okay, cool. So let's call this store. I always like to use the word store because it's just easy. And it tells me what it does. It stores things. Okay, so I'm going to create a set. Empty set. And okay, so I made that. The next thing is I want to add things to set. How to add to set. Set add Python. Yeah, so let's see, this is like 0, 1, 2, 3, 4, 5. It returns the length, so output is 5 nums. Output is 2 nums. Okay, so what's the output going to be? Change the remainder of the elements. So following strings equals this. Return the number of unique elements. Then return, so the relative order of the elements should be kept the same. Return the number of unique elements in nums. Return k. See, this is the annoying part with these outputs, right? Because this shows me the array and the number 5. 1, 2, 3, 4, 5. Unless this is just telling me that there's 5 unique numbers. Is that what it's trying to tell me? Okay, either way, all I have to do is first, let's just focus on adding things to set. So if I want to add stuff to a set, I just go dot add. So set dot add. set dot add nums I. So now store has everything in the set, and anything that's duplicated is basically omitted from that set, because sets only take a unique item. I guess that's why it's going to be an easy problem. So the second thing is I'm gonna get array length. So I want to get the original array length so I can fill up the empty spots of the set, because the set's gonna obviously have duplicates that are missing. So array dot length. So array length equals len nums. This gives me the length of numbers, and now I want to compare that against the set. So if the set is less than the length of numbers, so if the length of set is less than the length of numbers, then I want to add or subtract the length of numbers from the set length to figure out the difference of these underscores I want to add in these empty spaces. So if I have 3 elements here, right, my set is going to contain 2 elements. So the length is going to be 3 minus 2, 1. So now I have 1 underscore to add. If the set was 4 elements, if the array was 4 elements, I'd have 2 elements in the set, right? I have 1, 2, and then I add 2 underscores, because 4 minus 2 is 2. Unless you're like one of those researchers that says like 1 times 1 is 5 million. But I ain't that. Okay. So let's go back, store set, arr length, len nums, add to the set. So now I want to go diff equals len store minus array length. Alright, so now I have the difference between the length of the stores and the length of the set. Then I want to convert a set into a list. Convert a set into a list. You just have to typecast it. Okay, so S equals array equals list store. So now it's an array again. Then I want to convert now I have the list now, and I have the difference of length. Now I want to add whatever these elements are to the end. So it's going to be actually, first it says I just have to return k. Remove duplicates, calls your implementation, assert k. So nums I, expected nums. So I could just actually, without doing all this, just return my list. Let's see if that works. Because this like instruction here is kind of confusing, because it's showing me output and showing me a length and an array. And it's like, okay, what the fuck do I do with that? Right? Like, it's like, tell me what specifically you want and I could idealize it. See, like, most of the stuff is getting clear on it in your mind, getting clear on the English and how you describe it, and then you just convert your description into code, right? But when the objective isn't clear, then your thought process isn't clear, and now your code isn't clear. Code is just a language, right? So, like any language, if you're not clear, people won't understand the message. So if this instruction isn't clear, I won't understand how to output clearly. So I have to now assert things. So I'm going to assert by just testing this out. So before I go through the process of checking differences, let's comment out this code because it's an unnecessary line. Right now I just want to check if just returning a set of numbers is enough. For I in range 0 to things, set add nums I. if I'm going to say this, if len nums equals 0, return 0. Let's try that. For I in range 0 to nums, 0 to, nums, len nums. It should be length of nums. Okay, maybe that. Let's see if I can get rid of this base case, because if it's 0 to length of nums, there's nothing to add to the set, therefore 0. Actually, I could just do that. What's the length of the set though? What's the constraints? It has to be a minimum of 1, so this base case wouldn't even come true. If you look at the constraints, the second is nums in sorted non-decreasing order. I don't like how they say non-decreasing. Just say fucking increasing, bro. Okay, let's try it. Okay, what's going on now? Oh, I put set.addNums. It's store.addNums because store is the set. Let's try that now. Okay. So look, like as you go, you just uncover more and more. So 1, 2 is not valid for the expected return. Oh, because I'm returning the array. I have to return the length of the array. So I have to return the length of the array. So I could just go len r. Len r. Test case 1 is wrong. Test case 2 is wrong. Okay, let's see why. So this is my output 1, 1. My output is 1, 1. How? It's a set. It's literally a set. Okay, let's take it a step further then. If it's already doing this, I can just go store empty array. Like if it's gonna be this annoying, I could just go append. And then I don't have to convert it to a list anymore because it's not doing what I want it to do anyways. I can go len store. Then I add a conditional. I not in store. Store.append. Boom. Why? Why is it not doing this? Why is it doing this? If one, 1, 2. Okay. Something obviously isn't going right. So for I in range, 0 to length numbers. Right? Nums I, store, append nums I. Store.append. Okay. If nums I is not in store, append it to store. So now I go next. Why? Why is it outputting 2? I don't get what they want me to output. Your function should return k equals 5. The first 5 elements. It does not matter what you leave beyond the return k. Hence, they are underscores. What? I don't know what... Okay, so the confusing thing is, I don't know what they want me to return here. So it says return k, which is just the number of elements, right? So if if I just wanted to return the number of elements, change the array such that the first k element of nums contain the unique elements in the order they were present. The remaining elements of nums are not important, as well as the size of nums. Okay, I'm just curious. Let's try and crack this. Let's return store. Let's just see what goes on. Not a valid value. Expecting a return type integer. Okay, so k is going to be len store. See, this is why the judge will test your solution with the following code. Okay, so nums equals this. This is the input array. Expected nums, the expected answer with correct length. Okay. Remove duplicates. Assert k. Okay, so I might have to do it that way. So right now I just append everything to nums. Okay. The next part I have to do is, it's expecting 1, 2. I'm getting 1, 1. I don't know how that's the case. Let's go back to my set then, if we're gonna have to use that length. Let's just go back, add a bunch of this stuff. Okay, so let's get rid of this pause. Let's get this back. So AR length, AR list. Then I get the difference equals ARR dot length. No. So the difference is len nums minus ARR underscore length. That's difference. Then I append that onto this list of ARR. So append to a list in Python. Okay, so I want to find a way to add multiple. Extend a list in Python multiple by many items. Okay, add elements. Create a list of 10 zeros Python I'll put trailing equals, they're using underscores, so I'm going to go underscore underscore times n, or underscore times diff. That gives me the length of this new array. And then I'm going to go ARR dot extend trailing, return ARR. Boom. Store ARR equals the store, not valid. Okay, this is what I don't get. What is it trying to get me to pass here? Like example 1 is showing me these two outputs, right? So what I've done here is I create a set. Basically, I go through all the elements of the array. The way the set works is there's no duplicates in a set, so it'll only add the items that are unique. So everything will go up in order increasingly and be unique. The next thing is I'm getting the difference because it says to maintain the original length of the array. So I take the original length of the array, I minus it from the new array's length to get the difference. And then I just add a bunch of underscores to fill up the space. And that's what I'm doing with extend trailing. And I return ARR. Maybe it's because I'm using the name ARR. Let's type in LST. Let's try that. LST. Len LST return. What's going on now? 1-1 still. Okay, since the instruction is dog shit, okay, let's take a look at these hints. Together. Sorted. Focus on the info array being sorted as far as duplicate array is concerned. Positioning of the array. Okay, so if we're going by that, it already says the array is given an integer of non-decreasing, remove the duplicates in place such that the unique elements only appear once. So like theoretically, if you were to have this, if you were to remove it in place, it would be 0, empty space, 1, but the way they do it here is 0, 1, 2, 3, 4. This is why it's really annoying. Let's just see, because like this instruction is not clear. I could look at all the hints. Actually, let's look at the hints before we go to ChatGPT. Let's just see if the hints will clear it up any further. We need to modify the array in place, and the final one would keep track of the current element in place, the other one just for unique elements. Okay. Once an element is got, you simply need to bypass its duplicates and move on to the next element. I mean, set in Python. Can I set in Python a duplicate? Set in Python. When you have duplicates in a set in Python. Duplicate elements are not sets are unordered. Set elements are unique. So how am I getting the same element twice? So that's the case. I just toss everything into a set and it's done. So right now let's comment out all this. Let's comment out this. Technically you just need this. Toss it into a set. List.sort lst.sort. I'm just curious. What is happening? Okay, so len lst. Okay, so this is really dumb. So I don't know what it wants me to do. Like, it's showing a bunch of stuff here. So this is the thing that happens, right? You want to be as be as fair as possible when you're looking at this or when you're challenging yourself, but sometimes it's like, if it's not clear, then help me make it make sense. ChatGPT. Boom, these are the constraints. This is my code. Why doesn't it work? You maintain the relative order of elements after removing the duplicates. However, using a set followed by sorting doesn't guarantee the original order will be preserved. Okay. Modify the nums order in place such that the first k elements contain the unique elements. Oh, because it has to be sorted in place. Okay. So if that's the case, then I go back here. And let's reset this. Confirm. If not, nums return 0. Well, it's gonna be 1 for sure. And I guess use sliding window. So you have to use 2 pointers. So basically, it's saying you have to sort it in place. I think that's the big thing. We're in place such that each element appears only once. So we only care about the first one. Okay, so element equals 1, and while, okay, we can use range. What does it say here? If nums I is not equal to nums I minus 1, iterate through the array starting from the second element. Whenever you find a new unique element, nums I oh, okay, so k is basically just a counter for unique elements. Okay, so you're counting unique elements in order, I guess. Okay. So it's not actually just sorting and doing it like that. You're not actually sorting anything. You're just trying to find out what k is. Try in range 1, 2, when nums actually no, k is already going to be 1 because the first element is unique. If nums at I, so this is the current element and it starts at 1 because we skipped the first element because we already know k is 1. So if nums I, nums I minus 1, if it's equal to I minus 1, then we don't do anything because it's not a unique element. So we only increment k when it's greater than, so we only increment k basically when the items are unique. So when it's equal to its previous element, it's not unique. So we don't do anything. When it isn't equal to the element, then we have to k plus equals 1, and then we have to go, what do we do with nums? Nums k equals nums I. Okay, so we make it the, so we make the element, so nums k, so the number at 1 is equal to the current number. So basically whatever order of the unique elements it is, it'll come up as +1. Then we return. So we're basically modifying the original array to have the unique elements in order. And then we return the number of unique values. Yeah, see, it's gonna work because this is how the question was actually phrased. That makes it kind of weird. So this is the output here, and this is how the code's being tested. So even I got stuck on this. It's supposed to be an easy question, but the way it was explained is so poorly explained that it just doesn't make sense. So I'm gonna explain it to you in layman's terms. So basically, you get an array of numbers, this array, right? You can't make a new list. It says to sort it in place. So that means you want to take the exact same array as it is, and your solution needs to sort it within itself without creating new elements, right? So This is the nums array. We're only going to work with the nums array. Okay, now we know that the first element, it's a non-decreasing order. So that means the first element is going to be unique by default. It's going to be 0, or it's going to be 1. It's going to be 2, and it's only going to go up because non-decreasing is increasing, right? It's not decreasing. Non-decreasing means also it's not strictly increasing. It could be the same, right? So it could be 0, 1, 1, 1, 1, 2, 2, 2, 2, 3. You see what I'm saying? So it's like non-decreasing means you can have repeat elements, basically. That's why they call it non-decreasing. So if I have 0 already and I know that's the thing, I make k equals 1. That's going to be my index of the next element I'm going to check. So I'm going to check the current element is 1. I'm going to check the previous element to see if it's the same as element 0. If it is the same, do nothing. Move on to the next element. So now we're on index 2. We're checking against 0 again to see if it's the same as 0. Because k is still this number 1. No, yeah, k is still this number 1. We're only looking at I from range 1 and 2. So looking at I, we're comparing against number 1. Right? If nums I is not the same as nums I minus 1, so if it's the same number again, then we don't do anything. We go to the next element, I equals 3, right? But if it is not the same element, so now we have to increment k. So we started at 0, we're going to start here. We're checking this number. If nothing, go here. If nothing, go here. So right, k hasn't incremented yet, so it's still 1. So now that we found a new unique number, because the new number doesn't match the previous number, now we can increment. Nums k equals nums I. So this value of k, nums k equals nums I. So if nums I equals I minus 1, nums k equals nums I. And then k plus equals 1. So nums k right now is 1. Nums k equals nums I. The value at k is now going to be, what's it called? Nums k equals nums I minus 1. Because now you have to replace the value of k with the value of I. So nums k is 1, and now you're at 2. This value is different than this, so you want to swap them. So this k value now becomes this new unique swapped value. Then you increment k plus 1. Now we're on k equals 2, for example. Now we're on k equals 2. We look at k equals 3. If it's a unique value, we put it in k3. Then we increment k. So now we're basically sorting it in place as we go. And k is our reference point of where we're sorting it. Let's try submitting it. And boom, we have solved this question. So basically, the biggest part of the confusion is that you want to sort the array in place. If you know what element you're at, you have to create a reference. So we know the first one's unique. So we know element 0 is unique. So we start k equals 1, right? And then for every unique element after that, we just swap it with k. Boom, now we swap it with k. Boom, now we swap it with k until there's no more unique elements left. And then we just return k. K is the index at which, so k is the actual index. The first k elements, change the array such the first k elements of nums contain unique elements, return k. So k is your index of the unique elements. So 1 unique element, 2 unique elements, 3 unique elements, 4 unique elements, right? So that is it for remove duplicates from a sorted array. Hope you enjoyed. I know it's been a bit confusing with all this jargon in place, but we gotta start somewhere, right? And then we're just gonna keep getting better as time goes on. So if you have any suggestions, Comments, please put them in the video. If you liked the content, yeah, please leave a like and subscribe. It's your host, Kane Pear. Peace out.